Okay, a quick summary of the alkenes. This is from topic C7, lesson number 5. So the alkenes belong to a group of substances called hydrocarbons. As the name suggests, they're made from hydrogen and carbon only. We can also describe these as being unsaturated. Which simply means they are not full. We'll come on to what that means in just a moment. They also have what we call a general formula. So this is where we use a bit of algebra to try and represent the proportion of carbons compared to hydrogens. So what we're saying here is for every n number of carbons, we have twice as many hydrogens. Again, we'll show you how this works a bit later. And the other thing to remember with the alkenes is that they all have the same functional group. And the thing we're looking for is a carbon-carbon double bond somewhere in the molecule. The double bond we're talking about is a covalent bond. So we can call this the functional group. So let's have a look at a couple of examples. But before we do, we're just going to have a quick look at the prefixes for naming the alkenes. So I'm going to make a deliberate mistake on purpose. So if you've done your work on the alkanes, you'll know this sequence of prefixes. So we've got meth, eth, pro, bute, and then pent. And these relate to the number of carbons that each one of these molecules have. So anything with meth will have 1 carbon, then we'll have 2 carbons, 3 carbons, 4 carbons, 5 carbons. And I've made a deliberate mistake here, and you'll see why in just a moment. Right, let's have a quick look at an example. So first one we're going to do is ethene, apologies. So let's draw an ethene molecule. This is the displayed formula. Ethene will have 2 carbons. So here's carbon number 1, here's carbon number 2. And we need to have the functional group. We need to have the double bond, just a double bond, should we say. So that goes between the 2 carbons. Now, there's a little rule to remember in terms of the number of covalent bonds that certain atoms should have. So hydrogen will have 1 covalent bond with other molecules. Oxygen can have 2, and carbon can have 4 in total. We're not going to look at oxygen today, but it's worth noting there in case we do some work on other molecules a bit later. So to complete the rest of this molecule, we need to ensure that each carbon has 4 covalent bonds. So carbon number 1 has 2 already. So here's another one and another one. So it's got 1, 2, 3, 4. And now carbon number 2 has got 2 already. 1, 2, 3, 4. Let's pop the hydrogens in. And we can just count up the number of atoms and work out the formula. So we've got C2, 2 carbons, and 4 hydrogens, H4. Quick check to make sure it matches the general formula. C2H, 2 times 2 is 4, C2H4. Great, it all fits in. Let's have a look at another example then. So this was ethene. We're going to go to the next in the list, which is propene. Just about fitted in. We need to have 3 carbons. 1, 2, 3, there they are. One of them needs to have a double bond, so I'm going to do a double bond between carbon 1 and carbon 2. And then I'm going to add the rest of the bonds to the carbons to make sure each one has 4. So carbon number 1 already has 2, so that's 3, 4. Carbon number 2 already has 2 here and 1 over here, so it only needs 1 more. Pop that at the top. And carbon number 3 already has 1, so I'm going to do 1, 2, 3, so it's got 4 in total. Add in hydrogens, here they are. And again, let's count them up. 1, 2, 3, C3, H, 1, 2, 3, 4, 5, 6. Quick check of the general formula. C3, H, 2 times 3 is 6, and it all fits in. So this little section here relates to the number of covalent bonds that each one of these atoms can have. We've got ethene, we've got propene, we can do butene, and we can do pentene. But I want to go back to my deliberate mistake, which is to put meth in here. For the alkenes, we can't have methene because if we only have 1 carbon, we therefore can't make a carbon-carbon double bond. So this doesn't exist for us. Aside from that, let's just quickly check that we beat all the criteria for the alkenes. Each one of these is made of only carbon and hydrogen, so therefore it's a hydrocarbon. They're both unsaturated, and what I mean by that is if this double bond wasn't here and we had two single bonds, therefore either side, we could add two extra hydrogens. So a molecule with two carbons could have up to 6 in total, but it doesn't. So it's not full of hydrogens, and that's the phrase that we use when we talk about unsaturated. It's not full up with the maximum number of hydrogens that it can have. And the same with propene as well. Propene could have actually 2 extra hydrogens by breaking this double bond and putting 2 more in, so it isn't quite full up. So that's where the phrase unsaturated comes from. CnH2n, it all fits, and they all contain the functional group. So there's your 2 examples of ethene and propene, and you can do the same by just drawing the molecules bigger for butene and for pentene, and you can keep going on and on and on. Okay, so that's our overview of the alkenes.